Here we see the interior of an LNG storage tank. The camera is about to enter the liquid. The ITV camera gives a clear view of the state inside the liquid. This is the first time in the world that the interior of an LNG tank has been viewed from within the liquid. This has been made possible by the use of LNG tank internal observation equipment. Through the development of this equipment, the state of the tank interior, previously not visible to the eye, can now actually be seen by the eye through the medium of a camera, allowing very reliable verification. This has led to a higher level of reliability in LNG facilities. Liquefied natural gas, LNG, is being actively introduced as a new energy form in place of oil, along with nuclear power and coal. There are already over 100 LNG tanks used to store this, in operation nationwide in Japan. These tanks have earned a high reputation in terms of safety, from design to construction and maintenance. In addition, LNG has earned a high reputation as a clean energy form. LNG does not have corrosive properties and does not cause deterioration. Thus, there is no fear of the tank interior being damaged. Regular inspection of the empty tank is not thought necessary. However, as these tanks are expected to be used for long periods of time, it is necessary to devise some method of verifying the soundness of the interior of the tanks. If an internal inspection is attempted using conventional technology, there is no way of accomplishing this other than by emptying the tank. If this is done, the tank cannot be used for a considerable period of time, and it involves high costs. The LNG tank interior observation equipment, developed in a joint operation between Tokyo Electric Power Company and Mitsubishi Heavy Industries, has resulted in the creation of a system which avoids this waste of time and effort, and allows easy observation of the interior of the tank. This is a highly innovative system which allows observation of the tank interior in LNG liquid during operation of the tank. This equipment is made up of a camera assembly and a lighting assembly, and these units are placed inside the LNG tank. Power source units and control equipment are located on land away from the tank in a safe area. The system allows remote control from this location. The interior state can be verified using a TV monitor unit. Here we see the camera equipment assembly. The camera head incorporates a high-performance black and white ITV camera fitted with a 14 times magnification motor-driven zoom lens. The camera head is equipped with a pan tilt mechanism. This allows the camera to be tilted up and down and rotated to the right or left. In addition, the camera head can be moved up and down using the camera insertion and removal device. When this is used in combination with the pan tilt mechanism, all directions inside the tank can be observed. The lighting equipment assembly is made up of 8 small-size 500-watt halogen lamps. These are protected by a globe made of strengthened glass. At the same time, the interior is filled with nitrogen gas and is explosion-proof. As with the camera head, this lighting head can be moved up and down freely in the tank using the insertion device. Both the lighting and camera equipment assemblies are compact and lightweight, allowing easy transportation. By developing compact equipment, the setting within the tank can be performed using the existing nozzles. Thus, special equipment is not needed. And now we will look at the method of using the LNG tank internal observation equipment at the Futsu Thermal Power Station of Tokyo Electric Power Company. First, let's look at the installation method. The equipment is split up into several units to allow easy transportation and carried to the work site. The equipment is raised up to the stage at the top of the tank and assembled there. After assembly, the camera equipment and the lighting equipment are set in the existing nozzles and lowered into the tank interior. The procedure is as follows. First, the air remaining inside the equipment assembly is purged with nitrogen gas. The nozzle valve is opened and the equipment assemblies are lowered into the tank. Control panels and TV monitors are installed in a temporary facility at the side of the tank, and internal observation is carried out from here by remote control. And now we will see various visual images produced by the LNG tank internal observation equipment. First, we will see visual images of the initial cool down of an LNG tank that has just been constructed. We see the interior of the tank. LNG pours forth in a powerful stream from the nozzle of the tank. Here we see the wall of the tank during cool down. As cooling down proceeds, we can see that LNG builds up at the bottom of the tank. And now we will look at the interior of the tank when LNG is being received. Please observe the liquid surface at the center of the screen. The surface of the liquid is bubbling strongly. This confirms that reception of LNG has started. And now we will see the reception of the LNG during mixing. The mixing causes heavy bubbling. We can see that the LNG in the tank is being stirred. When additional LNG is added, bubbling different to that caused by mixing occurs. The start of reception can be clearly seen. The bubbling in the foreground is due to mixing, and the bubbling to the sides at the rear is due to the reception of LNG. About 10 hours have elapsed from the start of LNG reception. As the surface level of the liquid rises, the bubbling due to mixing and reception becomes smaller and a stable state is reached. Here we see inside the LNG after reception of LNG has been completed and a normal stable condition has been reached. The bubbling from corrugation shows that the generation of boil-off gas inside the tank has started under the liquid surface. This is a very valuable film, the first time this has been verified anywhere in the world. The LNG facility is already provided with disaster prevention equipment such as fire extinguishing equipment and water curtain equipment. sea, a marine disaster control ship effectively guards the safe passage of an LNG carrier. And now the LNG tank internal observation equipment has been developed to inspect and check the tank facilities. Using an ITV camera, the soundness of the interior of tanks can be verified and facility accidents can be prevented before they occur. In addition to the conventional safety precautions around the tank, the LNG tank internal observation equipment allows the safety of the tank to be ensured using a reliable visual inspection. Thanks to this, LNG facility safety measures have been made even more reliable.